Okay, today we'll be continuing on in 2.6, rational functions. We already went over vertical and horizontal asymptotes. Remember that video is on our Google Classroom from 1217, 1218. If you need some more details on how to do this, we'll quickly review it here in just a moment. And then we're going to get into these graphs of these rational functions. Today we're specifically going to talk about x and y-intercepts and how to find that, okay? All right, and we also went over slant asymptotes as well in the previous lesson. All right, so quick review here, how we find vertical and horizontal asymptotes. Vertical asymptotes are the zeros of d of x, which they're calling the denominator. However, you got to make sure you simplify out the common factors first. Okay, so let's quickly look at number 7, for example. To find the VAs, I can't just jump to the zeros of the denominator, where I'd have 2, a -2 and -1. I simplified and factored out the common factor up there. I factored the bottom, and then the x plus 1 reduced out. And then this is the result of the function now. So what are the zeros of the denominator? Now I only have 1. It's just -2. So there's a vertical asymptote at that spot, at x equals -2. Okay? All right, so there's your review on vertical asymptotes. For horizontal asymptotes, there's kind of 3 conditions, okay? It's all based on the degree, all right? So like I said, I'm not going to go through this in detail, but here's the 3 conditions. It's based on n, the degree of the numerator is what they're calling n, and the degree of the denominator, m, okay? If it's lower than it, it's y equals 0 every time. If they're equal, you divide the leading coefficients, okay? So where was it equal at? Number 4. Degree 1 over degree 1. So we took the leading coefficient of 3 and divided it by the leading coefficient of 1. Okay? All right, and sometimes the degree will be higher on top. So when the degree is higher on top, there is no horizontal asymptote. There might be a slant asymptote. So that happened on number 7. Degree 3 over degree 2. So you just say there's no horizontal asymptote when that happens. Okay. And then went over slant asymptotes. Once again, I went through all this in detail in the video, so revisit that as needed. All right, so let's go ahead and move on to the next page. This is page 49. Okay, now graphing these rational functions, to kind of expedite this year, we're really just going to focus on the characteristics. Okay, so on your test, you'll have to find horizontal asymptotes, vertical asymptotes, or slant asymptotes, and you'll have to find x and y intercepts. Okay, so I'm just going to focus on that skill today, x intercepts and y intercepts. Finding y intercepts is no different than what we've done in the past. You always let x equal 0. So find y intercepts. Like always, we let x equal 0. We've done that since the first part of chapter 1. We've never changed that process, okay? To find x-intercepts, we used to always let y equal 0, and we kind of do, but it's a little different for rational functions. To find x-intercepts, we find the zeros of the numerator and then solve that equation. They put n of x for numerator, okay? So for x-intercepts, simply put, it's going to be the zeros of numerator, okay? All right, so we'll put it all together tomorrow and put these graphs together. But all I want to do today for 11 and 12 is focus on part B, identifying these intercepts. Okay, we found the domain. Before break, we found asymptotes, but then we'll put it all together with intercepts in the graph tomorrow. Okay, all right, so for part B, identify all the intercepts. Let's just kind of break this up one step at a time. Let's go with y-intercepts first. Okay, so for y-intercepts, as it says up here, we're going to let x equal 0. So x is going to be equal to 0. Throw it into this function. Okay, you can replace f of x with y if you prefer, or you could write f as 0. Doesn't matter. I'm going to put y equals -3 times 0 all over 0 plus 1. And just evaluate it, and we'll have our y-intercept. So up top, we get 0. On the bottom, we get 1. 0 divided by 1 is 0. So what does that mean in a coordinate form? It means we have a y-intercept right there at the origin, 0, 0. Okay? Okay. X-intercepts, just another reminder. It's up here in the box, but I'll, for this first one, keep writing this down. We need to find the zeros of the numerator. I'm going to use n of x to distinguish the numerator. Okay, so the zeros of the numerator. So all I got to do is take negative 3x, set it equal to 0, and find the zeros, and just solve this equation. Simple math. It's just a matter of remembering the process, that's all. Okay, so divided by negative 3, we get 0, which not a surprise because we just had the origin here. Okay. All right, I want you guys to try it for number 12 at home. Go ahead and pause now and try 12, and we'll go over it. I did forget to tell you guys to simplify the function first. So if you already tried 12, kind of redo it. Simplify the function first. Try to factor out the common factor in the bottom and reduce it if possible, which is possible. Okay, so try that, then find your intercepts. Okay, so here's the simplified form of this. It's denominator factors the x plus 1, x minus 4. Common factor of x plus 1 divides out. And so we're left with 1 over x minus 4 is kind of your new function you're working with. Okay. All right, so the y-intercepts, we replace x with 0. Plug it in, we get negative 1/4. Or in coordinate form, 0, negative 1/4. Okay. For the x-intercepts, when you just have a number up top, there aren't going to be any zeros. Or if you tried to set 1 equal to 0 and solved it, you wouldn't have a solution. So there are no zeros in the numerator in n of x. So that means there's no x-intercepts. Okay, that's how we interpret that. All right, the last one, if I compare it to 11, it had, an expression up there like negative 3x. So negative 3x set equal to 0, divide by negative 3. In this case, we couldn't do that. Okay. All right, let's try this one more time. Try to simplify 13 first, and then find your x and y intercepts. Okay. Okay, here's your feedback on the intercepts. Try to simplify, and there were no common factors to divide out. So we just move forward with this or that. It's up to you. So when I plug in 0, I plugged in 0 into this one, but you could definitely get by with doing it on that one. So I get negative 3. So here's my intercepts, y-intercept, that is. X-intercepts, it's the zeros of the denominator. I'm sorry, numerator. So I take this, use the zero product law now, set A or B equal to 0, solve them, and I get 2 x-intercepts. Okay, so let's go on to vertical asymptotes. Vertical asymptotes, they're the zeros of the denominator. Okay, so x-intercepts are the zeros of n of x. This is just the zeros of the denominator after it's simplified. Okay, we already tried to simplify it. We couldn't do anything with it. So the VA will be VA. So we're going to take the denominator, x plus 1, and we simply set that equal to 0 and solve that simple equation. All right, so it's at x equals negative 1. So we just say there's a VA at that spot. Don't just say negative 1. The vertical asymptote is going to be a vertical line that we're going to draw on the graph. Okay, so x equals negative 1 describes a vertical line. Okay, so for horizontal asymptotes, we got to analyze the degree of the top and bottom. That's what all of these 3 steps go over. Degree of the n compared to m. Okay, so the degree of the numerator is 2. The degree of the bottom is 1. Okay, so right now, n is greater than m. 2 obviously is greater than 1. So when n is greater than m, what does it say when that happens? The degree is higher on top. The graph has no HA. That's it. There might be a slant asymptote, but there is no horizontal asymptote. So all you got to say is no, write out the words or just abbreviate it if you want. Okay. Okay, that's it for today.